So now in this video we're going to do a step-by-step of wiring the 555 timer. This is an NE555. Its pins fit in the board pretty nicely. They're a little wider than the board. You just kind of squeeze them and they slide in pretty well, and the board holds them pretty well, and the power supply is off. So in any case, we have a little groove up here, a little partial circle. Sometimes there's also a indent of a circle right here, but that lets you know that's the top of the 555 timer. And if you look at the data sheet or whatever, the pin layout is going to be top left is pin 1, 2, 3, 4. This goes with all these dual inline package ones. Some of them are longer, you keep numbering down, but you get to the bottom, so 4 here, then you jump across. So we got pin number 5, 6, 7, and 8. So first thing we're going to do, we're going to wire an astable mode, but this goes with all 555 timer circuits. We need to power it. So the pin number 1 goes to ground, our negative rail, and then pin number 8 goes to the positive rail. So this powers all the things that the timer does, and also there are 3 resistors across here, and so there's 2 points that it contacts for 1/3 of the power supply voltage, and then 2/3 of the power supply voltage, and that really comes into play in this circuit. This circuit highly depends on that. Now we have pin number 5 here. This is the reset pin. If it goes low, if it goes close enough to the negative rail, it resets the 555 timer, which overwhelms anything else that's going on, and we want to eliminate that happening, so we're going to put it to the positive rail. So that keeps pin 5 from doing anything, and so we have pin 5 taken care of. Or pin 4 here. Sorry, that's pin 4, not pin 5. Pin 5, that one, sometimes you'll see a little capacitor there to help with stability issues and stuff. That doesn't really come into play with any of the circuits I've done so far, so I'm not going to add it. It's just one more component to try to keep track of. But you may see a little capacitor on pin 5. So now we're going to get to the primary component for the timing. And so here I have a 10 microfarad capacitor, and I don't think we will see the number. Okay, you can see the numbers alright. So 10 microfarad, it's rated for up to 50 volts. So as long as you don't charge it above 50 volts, you're safe as far as the capacitor is concerned. This side has to be more negative though. So we make that really easy. We plug the short lead into the negative rail, and then the long lead up here we're putting to pin number 6. So pin number 6 is the threshold pin. So that's going to monitor the voltage of the capacitor here. We are going to take a jumper and we're going to short pin 6 to pin 2, because pin 2 also monitors the voltage of the capacitor. And so when the capacitor gets to below 1/3 of the power supply voltage, I mentioned that before, then the pin number 2 is the trigger pin. That jumps into action, it triggers it, and it sets the output high. And in the same process, the capacitor starts charging. We'll add those components coming up next, but it charges up to 2/3 of the power supply voltage, and then the threshold pin jumps into action, sets the output low, and discharges the capacitor through pin number 7, and it keeps bouncing back and forth like that. So we will add those resistors now for that part. So pin number 7, first we will take, this is a 10 kilo ohm resistor, and you can use different values as long as current doesn't get too high. It doesn't matter what values you use. If we used a smaller capacitor for a given current, it will charge faster. If we use a larger value capacitor for a given current, it will charge slower. The resistors that we are using will, lower value resistors will provide more current, and then higher value resistors will provide less current, so the capacitor will charge slower or faster based on the current that it's getting. So more current, faster charge, less current, slower charge. So it's a balance. You can adjust the capacitor the resistors, or both. And now we're going to take this resistor. So we have this one going to the positive rail, which you couldn't really see. There we go. And this one we're going to put connecting pin 7, the discharge pin, to pin 6 with this resistor. And I'm kind of keeping it cramped here for a reason, but we'll get to that later. So there we have it. And now we're all done wiring up this 555 timer as an astable multi-vibrator, but there's no load yet. So it will turn on and off, but there'll be no load for us to know it's even doing anything. So what we're going to do, take a 220 ohm resistor. The output is pin number 3 right there. And we're going to wire that one row away from this gray jumper down here. And doesn't really want to go in right next to the pin 3, but there we go. So we're one row away from the jumper. Jumper goes to the negative rail. We're going to light an LED. And so we have the cathode, the short lead, it's going to go to where the jumper is. The long lead, the anode, is going to go up here. And now I will turn the breadboard power supply on. By the way, it's just a button there. These boards are really nice. But in any case, when I turn it on, you can see that the LED is flashing. So now it's flashing fairly quickly. It's not terribly nice. So what we're going to do, it'd be better to turn off the power, but we can yank the capacitor out, and now there's a positive signal going through that resistor and that resistor to pin number 6 here, the threshold pin. So the output is staying high, but we will swap out the capacitor with a 47 microfarad capacitor, so basically 5 times the capacitance. And when I plug it in there, now it is flashing about 5 times slower. So more capacitance takes longer to charge for a given current. If we use 2 kilo ohm resistors instead of 10 kilo ohm resistors, we would get that same speed flashing that we had last time. But that's a good enough demonstration, I think, to understand that principle. So now the LED is on for probably about twice as long as it is off. It's kind of off quick and then back on, and just kind of stays on for a little bit. So we're going to take a diode, because the capacitor has to charge through 2 resistors until it gets to 2/3 voltage. When it hits 2/3 voltage, according to pin 6, that's what it's monitoring, then the capacitor starts discharging through the 1 resistor to pin 7 straight to ground. And so what we want to do, we want to charge through 1 resistor and then a diode. So the diode won't really offer any resistance, none to really mention. It will have a little voltage drop, so it's not a perfect wire in one direction, but it's going to, for the most part, let current freely flow around that second resistor. And so we will put that there, and the eye can only sense so much, but right now we should see that it is on and off about equal amounts of times. And so we can make more adjustments with the resistors to influence the on-off time, and there's some other things you can do. But for this video, I'm just kind of introducing this component to people completely brand new while it is in astable mode. So now the output, when the LED is on, the output is high. When the LED is off, the output is low. And so it's not just turning on and off, it's going from high to low. So up here we have the positive rail. Let's grab a 1 kilo ohm resistor, because I think the green LED is going to be brighter, so I want less current. But I'm going to put the resistor to the output and then 1 row away from the positive rail right there. And it can touch that resistor because they're plugged into the same pin anyways. So it's 1 row away. Now we will grab a green LED, and the long lead, the anode, is going to go to the positive rail, and short lead, the cathode, is going to go to the resistor. And so when it turns on, you know the output has a lower voltage than the positive rail. And so we'll plug that in there. And you can see that it is on when the red LED is not on. And a lot of my circuits that I've done recently, I made it where, or actually, yeah, we know what the output is right now. When the red LED is on, I have it wired so that it is on when the output is more positive. And because it has to be more positive because it's going to the negative rail. I have the green LED wired up so that it is on when the output is more negative. So as long as you understand the wiring of the circuit, you based on the color of the LED, you can tell what the output is doing based on which LED is lit up. So in any case, hopefully that all made sense. These are topics I covered before, but it's good to do a refresher and an introduction to people that haven't watched my previous videos and haven't, even if you studied the circuit before, if you haven't built it, hopefully this step-by-step build made it a lot easier to understand what an astable multi-vibrator 555 timer is doing if you've only seen the schematics or heard it described before. So thanks for watching. I will see you in the next video.